This is your stat sir, your Ravishankar sir. ఈ వీడియోలో లెక్చర్ స్టార్ట్ చేయబోయే ముందుగా మన మంచి మాట. మనం జీవితంలో చేసే ప్రతి పనిని కష్టపడుతూ ఇష్టపడద్దు, ఇష్టపడుతూ కష్టపడండి. తప్పక ఉన్నత శిఖరాలను అధిరోహిస్తారు. So with this quotation, I would like to start the third unit for 5th semester students, that is stratified random sampling and systematic sampling. As the title suggests, Unit-3 consists of two topics. One is the stratified random sampling and second one is systematic sampling. So I am dividing this unit into two chapters. Chapter 1 is the stratified random sampling and chapter 2 is the systematic sampling. So first let us have a look at the contents of these chapters. Chapter 1 is stratified random sampling. It consists of definition of stratified random sampling, advantages of stratified random sampling, notations and terminology, concept of proportional and optimum allocation, theorems in stratified random sampling, and problems in stratified random sampling. Chapter 2 is systematic sampling. It consists of definition of systematic sampling, notations and terminology, theorems in systematic sampling, merits and demerits of systematic sampling, and problems in systematic sampling. In this part, we are going to deal with chapter 1, that is stratified random sampling. Again, stratified random sampling is divided into several parts. This is the first part. This video is the first part. In this part, we are going to discuss about definition of stratified random sampling, advantages of stratified random sampling, notations and terminology. First, let us have a look at the definition of stratified random sampling. So, stratification means a division into layers. Auxiliary information, that is past data or some other information related to the character under study, may be used to divide the population into various groups such that units within each group are as homogeneous as possible and the group means are as widely different as possible. So here the stratification means a division into layers, that is we need to divide the population into several subgroups or several layers, and among from those layers or those subgroups we need to select the samples. So let us represent this in a diagrammatic way. So in this slide I am considering a population denoted with a rectangle of size capital N, and this population is divided into several subgroups, and those subgroups are denoted by circles. Here there are 6 subgroups in this particular diagram. This is subgroup 1, group 2, group 3, group 4, group 5 and group 6. So each group comprises of capital Ni number of elements. Group 1 consists of capital N1 number of elements. Group 2 consists of capital N2 number of elements. Group 3 consists of capital N3 number of elements. Group 4 consists of capital N4 number of elements. Group 5 consists of capital N5 number of elements. Group 6 consists of capital N6 number of elements. Such that, so that capital N is equal to summation I is equal to 1 to 6 capital Ni. So we are dividing the population into several subgroups. So these subgroups are called as strata. These subgroups are called as strata. Several subgroups together called as strata, and each subgroup is called as stratum. Each subgroup is called stratum. So now from this population consists of several subgroups. I need to select the samples from each subgroup. I need to select a sample of size small n from each subgroup. So this is a group of elements, part of the elements taken from group 1. And this subgroup in the sample comprises of small n1 number of elements. And the second subgroup comprises of small n2 number of elements. These n2 number of elements have been taken from group 2 in the population. Similarly, the third subgroup in the sample comprises of small n3 number of elements, and these n3 number of elements have been taken from group 3 in the population. Similarly, group 4 in the sample comprises of small n4 number of elements, and these n4 number of elements can be taken from group 4 from the population. Similarly, group 5 and group 6. So all these subgroups in the sample comprises of the required total sample. So that here small n is also equal to summation I is equal to 1 to 6 small n. And all these samples have been drawn from each subgroup by using simple random sampling without replacement. So by dividing the population, by selecting the sample, the selection of sample by dividing the population into subgroups is called the stratified random sampling. Thus, a population consists of capital N sampling units is divided into k relatively homogeneous, mutually disjoint subgroups known as strata of sizes capital N1, capital N2 and so on capital Nk, such that capital N is equal to summation I is equal to 1 to k capital Ni. From each stratum, a sample is drawn using simple random sampling, generally without replacement, of size small ni, is drawn from each stratum respectively such that small n is equal to summation I is equal to 1 to k ni. The sample is termed as stratified random sample of size n, and the technique of drawing such a sample is called stratified random sampling. And next one, advantages of stratified random sampling. The more representative, first one is more representative. Usually in some sampling techniques like simple random sampling, some groups may be overrepresented, some groups may be underrepresented, and some may not represent at all. Stratified random sampling techniques will be useful to represent all the subgroups in the population. In the previous videos, in the case of simple random sampling, we discussed about one example of conducting a seminar. So, I want to conduct a seminar in a seminar hall with the seating capacity of 300 students. In simple random sampling, I was selected 250 students from the final years and 50 students from the second years, so that final year students are overrepresented, second year students are underrepresented, and first year students are not represented at all in attending the seminar. But instead of that, if we divide the second years, final years and first years into several groups, and from each group I was selected some number of elements, then all the groups will be represented in the sample in a good manner. So stratified random sampling helps in that aspect. Second one is greater accuracy. Stratified random sampling provides more accurate results by providing the best estimates with increasing precision, since it enables us to obtain the precision for each stratum. And the third one is administrative convenience. In stratified random sampling, the samples will be concentrated more geographically as compared to simple random sampling. Hence, the time and money involved in the collection of data and interviewing the individuals may be reduced to a great extent. The supervision of fieldwork also may be done with greater ease and convenience. And next, notations and terminology. So here, before going to prove the theorems in this particular stratified random sampling, we need to have an idea about the notations which are used in those theorems. So in this part, we are going to discuss about such kind of notations. Here, let n be, capital N be the size of the population and small y be the character under study. Let the population is divided into k strata of sizes capital N1, capital N2 and so on capital Nk. Here strata means the group, the combination of several groups. So that capital N is equal to summation I is equal to 1 to k capital Ni. Let us suppose that a simple random sample of size small ni using simple random sampling without replacement is drawn from the stratum of size capital Ni, where I is equal to 1 to k, such that small n is equal to summation I is equal to 1 to k Ni, as we discussed in the previous slide. So here capital N represents the total number of population units. Capital Ni represents the number of population units in the ith stratum. Small ni represents the number of units selected in simple random sampling without replacement from the ith stratum. Small n is equal to total sample size drawn from all the strata. Next one is, let capital Yij be the value of jth unit in the ith stratum. Suppose if we are dividing the population into several strata, so those stratum numbers can be represented with 1, 2, 3 and so on I and so on k. So each stratum comprises of the elements capital Y11, capital Y12 and so on capital Yn1 in the first stratum. Similarly, in the second stratum, capital Y21, capital Y22 and so on capital Y2N2. Similarly, in the ith stratum, capital I1, capital I2 and so on capital Yin. Like that, here capital Y11 represents the first unit in the first stratum. Capital Y12 represents the second unit in the first stratum. Similarly, capital Yij represents the value of the jth unit in the ith stratum, where I is equal to 1 to k and j is equal to 1 to capital Ni. And the population mean of the ith stratum, that means we need to calculate the mean for each stratums. That is the sum of the observations in each stratum divided by the number of observations. So the population mean of the ith stratum is denoted by capital Y Ni bar and is given by the formula 1 by capital Ni into summation j is equal to 1 to Ni Yij. Overall population mean is denoted by capital Yn bar and is given by the formula 1 by capital N into double summation Yij. This also can be written as 1 by capital N into summation I is equal to 1 to k capital Ni into Yn bar, because from the above expression population mean of the ith stratum, Yn bar is equal to 1 by Ni into summation j is equal to 1 to Ni Yij. From this formula we can write summation j is equal to 1 to Ni Yij is equal to capital Ni into Yn bar. So we are substituting this in place of this. Summation j is equal to 1 to Ni Yij. So that we will get summation 1 by n into summation I is equal to 1 to k capital Ni into Yn bar. that is equal to summation I is equal to 1 to k pi into Yi bar, where pi is equal to capital Ni divided by capital N is called the weight of the ith stratum. Next one, population mean square of the ith stratum is denoted by capital Si square, which is equal to 1 by capital Ni minus 1 into summation j is equal to 1 to Ni Yij minus Yi bar whole square. Overall population mean square is represented with the capital S square, which is given by the formula 1 by capital N minus 1 into double summation Yij minus Yn bar whole square. Let Yij, small Yij, be the value of the jth sampled unit drawn from the ith stratum. So mean of the sample selected from the ith stratum is denoted by small Yi bar, which is given by the formula 1 by Ni into summation j is equal to 1 to Ni Yij, where I is equal to 1 to k. Mean of the stratified random sample is denoted by Yn bar, which is equal to 1 by small n into double summation Yij. It is also can be written as 1 by n into summation I is equal to 1 to k Ni into Yi bar from the above equation of ith stratum sample mean. And then sample mean square of ith stratum is denoted by small Si square and is given by the formula 1 by Ni minus 1 into summation Yij minus Yi bar whole square, where I is equal to 1 to and so on k. Stratified sample mean square is denoted by small s square, which is equal to 1 by n minus 1 into double summation Yij minus Yn bar whole square. We consider two estimates of the population mean Yn bar, capital Yn bar, which will be given below. So stratified sample mean is denoted by small Yn bar and is given by the formula 1 by small n into summation I is equal to 1 to k Ni into Yi bar. So if small ni divided by small n is equal to capital Ni divided by capital N, then stratified random sample mean considered as Y bar St and is given below. So that is Y bar St is equal to 1 by capital N into summation I is equal to 1 to k Ni into Yi bar, which is equal to summation I is equal to 1 to k pi into Yi bar, where pi is equal to capital Ni by n, which is the weight of the ith stratum. So these are various notations and terminology which are going to be used in the derivation of theorems of stratified random sample. So in the next video, we are going to discuss about some simple theorems and the concept of proportional and optimum allocation. So thank you for your patience listening.